Let's tackle day 11 of Advent of Code 2024. So we have Plutonian Pebbles today. They are arranged in a perfectly straight line, and each stone has a number engraved on it. And every time we blink, the stones change. Sometimes the number changes, sometimes the stone splits in two, causing the other stones to shift a bit to make room for their perfectly straight line. So there are the stones simultaneously change according to first applicable rule in this list. So if the stone has number 0, it's replaced by number 1. If the stone is engraved with a number that has even number of digits, it's replaced by 2 stones. The left half of the digit is engraved on the left stone, the right half on the right stone, whereas the new numbers don't keep extra leading zeros. So yeah, 0, 0 becomes just a 0. If none of the other rules apply, we multiply the number on the stone by 2024. Right. No matter how the stones change, their order is preserved. Okay. Now we have some example here. So if this input, this becomes this because this is even number of digits. Now this becomes 253 and 0 because the leading zeros are just replaced with 1 0, and this is multiplied. This becomes multiplied, and it just continues on and on. So after 6 blinks, we get 22 stones, and after 25 blinks, we get 55,000 stones. So that's quite a number. So our question here is, given the arrangement that we are given, which is this initial arrangement, how many stones we will have after blinking 25 times? Okay, so we can try to brute force it. It will be more than 55,000 stones because we are starting off with more right away, but hopefully not that much more. So well, let's start with just this one. So I will put the test data there. And let's do something like so what how do we so we apply a rule. Apply rules. We'll be given number and a list of string next. And what we will do is, given the number, we will check if let's keep it as a string because those numbers could be really large, and we want to make sure that it really fits. So this is already quite a big number, so we'll be using big integer for if necessary. So if the number is equal to 0, then we will add just 1. If number, what is the rule? The second rule. If the second stone, if the stone has an even number of digits, length modulo 2 equals 0. If it's even number, then we will break it down into 2 parts. So half number half. So exactly. So we will take the 2 substrings and also make sure that we remove the leading zeros. So, so we'll have to trim start, and we will trim the zeros. Oh, right, it's a car. So we'll trim zeros. And if we end up with an empty string, we will just make it a 0. So this is 0. So then we do next add left, next add right. So we add what we got. Actually, let's just do apply rules. So let's well, actually, let's first read the input. Input age read to end is saying we'll just read the whole thing, and then let's split it by spaces this time, right? And we will then we'll have the numbers then. So the list, and for 25 we'll do new state. For each number in current state, we'll apply rules and add to the new state, and finally replace the current state with new state. Yes, so that's what we will be doing, and finally returning the length of the final state. And what we will do now is that we will also check the final rule. Let's see. If none of the rules apply, we replace it by the new stone, which is multiplied by 2024, and then we will use the big integer. So integer, and can we parse it this way? No, it's like a big integer parse number. And we will do big number multiple times 2024, and then we will add it there. So those are the rules that we are applying, and we should be good to go with this. So what we can do is to see if for this data we will get the right result now. Right. So I will run the test data. Value couldn't be parsed, so we have something that was not parsable. So let's see. 125. Oh, there was something weird. So we need to okay, so we'll trim it. So we'll trim the input as well. White space characters, yes, because there was a white space new line character at the end, so that was a problem. So I think that should be good now. And it's 55,312. And that's correct. So let's see what happens with the full blown input that's provided to us. So it's this huge number, and that's a correct number. Okay, so we have the first part finished, so let's go on to the second part. Oh, it's very short description. So we need to know how many stones we will have after blinking 75 times. Well, that's certainly worse, because 75 times we probably would wait for it for a long time, because the number of numbers would increase significantly. But of course we can try it. Against test data. Okay, you can see the memory increasing significantly fast, but yes, so all right, already a huge number of numbers. But the interesting thing is there's a lot of them are repeating, so it's repeating all the time. Right, so this is not the way to go. But if there are like they say the order is preserved, but the order doesn't seem to matter at all. Like if we have the numbers there, replacing them, we just simply replace them, and it doesn't matter where the stones are. We just care about which numbers are there, and it seems like the numbers will start repeating a lot. So like it's not necessary to process two separately from this two and this two, because it's always gonna end up with the same rule applied. So essentially we could just track the number of for each unique number on the line, we could track how many of them are there, because they will be processed the same way. So essentially we wouldn't have to care about where they are, just how many of them they are. So let's do it like that. So we'll have instead of a list, we'll have a dictionary. Stone counts, where the string will be the number on the stone, and the int will be the number of such stones in the current well, let's call it current state, actually, in the current state. So numbers group by well, we'll need this, right? Oh, it's into list, right? Okay. So this will kind of add the numbers with their counts, the initial numbers with their counts to the dictionary. I think it's in the test data and in the input data that I got are still unique anyway, so it doesn't really matter that much, but it's a kind of future proofing against arbitrary input. So now with the current state, so we'll go for 75 and new state, and for each number and count, we'll have a new state, which is going to be dictionary of string int again. And we will have a method like if it's already there, we'll add the value, or if it's not there, we'll add a new entry. So now, if the number is equal to 0, we'll just say add or update. We'll add the count of, we'll add ones at the count that we are given. We'll just replace all the zeros with all the ones. Then if the number is module 2, we'll add or update. Basically, it's going to be just replacing all of these references to add to be something like this. And the same here. So I think this should actually be enough of a change to make it work. But instead of having a list of potentially repeating numbers, you'll have just a dictionary giving us the numbers themselves, the counts of the numbers. So if you're not with this data, is 2, which is definitely too small of a number, but we actually are not counting it correctly, so it's going to be sum of values. So this is the correct calculation. Still 2, that's weird. Wait. So what we need to check here? Well, actually, if I do with 25, we should get the same result as in the first part of the problem, right? So we can check it. So we have number 1 to 5 and count of 1. There's nothing in the new state, so oh, of course. That's a big mistake here. I didn't update actually the current state with new state, so now this should be much better. So what happens if I run it? 55312, which matches the expected result. So now with 75, okay, there was an overflow. Right, so the only thing they could have overflown is the value, the number of occurrences. So I'm guessing I will have to do longs there. Probably. All right, so this is a big number. And let's see what it says for our input. Very, very big number. So let's try. And it is correct. Okay, good. So we completed day 11 of Advent of Code 2024. So far, so good. I will be doing another video, as usual, to see if ChatGPT can also solve this problem. And I guess I will see you on day 12.